What we see here is the plot of the PID control, where we see two different tests, one which was insulated and the other which was out in the open. We see that they both overshoot the target temperature of 17.5, but they both near this 17.5 after a while. We would like to have seen a few more hours to see if the insulated, the red one, could stay around this temperature.
Welcome to the final version of our website. So in the past review meeting, I explained all the behind the scenes process, so how the front end and back end work together, all the MQTT server stuff, how our data is saved to our Mongo database, and now we're just going to dive in how the actual website looks like and go through all the features. And yeah, so this is the main page. It has some nice handmade floating icons in the back. And we're going to start with the About Us page. First, we're welcomed with this beautiful ocean GIF. And if we scroll to the bottom of the ocean, we can see the day before dream team, which is us. So each of us has a custom muscle that has, funny characteristics about us and, a biography, just talking a little bit. Nothing interesting, but it's pretty nice. And we wanted to make it personal, so there it is. And if you want to take a deeper look, obviously, just ask. Going back to the main page, this cool button, let us go into the muscleverse, which is the stuff you as teachers are interested in. So sadly right now it's late at night, so the system, we don't have it running, so nothing is displayed in real time, but obviously in person during the review meeting you will see it. So again, thanks to the MQTT, the values that the sensors are reading for both temperature and optical density, which are the main parameters that we're interested in, are displayed here in real time, as well as the current temperature and the current optical density. We also added this muscle mood tracker, which based on the values here tracks the emotions that the muscles might be feeling. So this matrix takes ranges of temperature and optical density and says, okay, is there too much food or too little food? Is it too hot or too cold? And depending on that, this mood will display a muscle with a different facial expression. So yeah. And then the last feature is this gorgeous big floating board button. So this shows that we're not only able to receive data from the board, but also send data to the board, because when we press it, don't go away, here, we get the option to abort the whole system. So just kill the system, basically stop everything, and yeah, we don't want to abort right now because there's nothing running. But yeah, that's about it. That's our website. I hope you like it.
For our OD sensor, we use the centrifugal tube as the main housing, with the LED launched in the tip and the RGB sensor in the lid, giving us a long through shot in the algae water. To make sure it was light isolated, we wrapped the whole system in electrical tape and further secured it with a cardboard box over the whole tube, thus ensuring no light will interfere with our readings.
For our OD sensor, we also made a plot from our measurements to try to find the relation between the measured OD from the RGB sensor and the concentration of algae. By doing that, we got this model that shows the relation between the OD and the concentration of algae.
So we have also conducted a biocompatibility experiment. We have tested our plastic tubing, our plastic film, and the centrifugal tube used for the OD measurements. We've done 3 tests of every single one of them. And we've also conducted a ANOVA test to see if they are the difference in means are statistically significant. They are not, as the p-value is over 0.05.
These are some of the experiments we've done. Some we have presented. For the ones we haven't presented, please feel free to ask about them during the presentation. On the right side of the slide, you'll be able to see our characterization for the pumps and for the siphon. To find the perfect value, PWM value for the feeding pump, to find the perfect flow rate that will match the siphon, we found the intersect between the graph for the pumps and for the siphon.
For sustainability, we made a lot of improvements to our system. These were insulating the box, using a box from the recycling center to make the cooling more energy efficient. We used one less pump by replacing it with a siphon, meaning we are using less power. We used a recycled date box for light insulation of the OD sensor. We only used the small pumps as they require less power. And lastly, we didn't put any holes in any of the buckets.
With regards to safety, we've made a risk assessment report where we have identified a few hazards and identified the risks associated to them and assessed them.